Hello and welcome to Sean White's Solar and Energy Storage Podcast. In this issue, we're going to talk with Bill Brooks about the International Residential Code, that's the IRC, and energy storage systems, that is ESS. In this podcast, Bill Brooks covers the International Residential Code from the International Code Council, and that's the ICC, and that's the rules in addition to the NEC for installing energy storage systems in 1 and 2 family dwellings. Bill Brooks is instrumental in writing the material that we cover and sits on many different panels, such as the UL 9540 Standards Technical Panel, and comes up with the rules. And then stay tuned for another podcast where we will cover the International Building Code, that's the IBC, and the International Fire Code, that's the IFC, and those are used for other than 1 and 2 family dwellings. Here in this podcast, we're going to cover UL 9540, that's the umbrella standard for energy storage systems, UL 1973, UL 1741. We're going to cover the 2018 IRC, the 2021 IRC. We're going to talk about some of the 2024 IRC insight. Some of the brands that we're going to talk about are the LG Chem Battery, the Tesla Powerwall, SolarEdge, SMA, BYD, Enphase, Sonnen. Then we're going to talk about inverters and sub-assemblies, and of course, lithium-ion batteries, which we're mostly going to talk about, with some mention of lead-acid battery preferred applications. Then we're going to talk about the interesting concept of using retired electric vehicles to power your house according to the 2018 IRC. That's very interesting. We're going to cover a little bit about NEC 625, which is about bidirectional electric vehicle charging and discharging, of course, because it's bidirectional. We're going to talk about battery locations, habitable locations, ventilation, hydrogen, and flammable gases, protection from impact, that's vehicle-approved barriers, parking bollards, parking curves, and more. And although this podcast's focus is on residential energy storage systems, we do mention some utility-scale energy storage system relationships with UL 9540. That's the umbrella standard for energy storage systems. To have fun and learn more about solar and storage, go to Solar, SEAN, that's solarshawn.com. And here we go, on with the show. So another code by the International Code Council comes out once every 3 years, and the IRC is what you use for residential, not the IFC.
Right, and it's for 1 and 2 family dwellings. So residential that's other than 1 and 2 family dwellings would be covered typically by the building code and the fire code. So R3 construction is considered part of the fire code. And the fire code does have more in it in the 2018 version than the 2018 IRC. And so some fire departments have said, well, because we don't like how little information's in the 2018 IRC, we want to use the IFC. That's not how the rules work. So for 1 and 2 family dwellings, what is in the IRC are the rules. So let's get into some of those rules. R327, okay, so that's where in the 2018 code they've moved these material. R327, this is a general outline, talks about listings, installation, ventilation, and protection from impact. When we get into protection from impact, that's where we're going to talk about things like vehicle protection.
Yeah, and I notice it's really short, so this whole section on energy storage batteries is less than half a page. Also notice too that the NEC, which we also have to follow, 480 is storage batteries, and 706 is energy storage systems. So now they call it storage battery systems, so it's sort of a hybrid.
Yeah, and the 2021 changes that to energy storage systems. So the first thing it says, and this is the big change in the 2018 code, is that stationary battery systems shall be listed and labeled for residential use in accordance with UL 9540. Now the residential use portion of this in 9540, it's not a big deal, and so we're going to set that issue aside because it's going to get confusing. But UL 9540 is the safety standard that has been developed, and it's a very new standard that has been developed to address this very specific requirement that all, not some, but all battery systems that are in residential applications must follow UL 9540. Now, what isn't necessarily 100% clear is if it's outside the building and a certain distance from the building, could it be something other than UL 9540? The answer is probably yes. But if you're considering putting energy storage on a residential 1 and 2 family application, you are going to need UL 9540 certification for that equipment. That being said, the only equipment as of this recording that is UL 9540 are all lithium-ion batteries. So 100% of the UL 9540 products that are on the market today for residential are lithium-ion products. That will change in the near future, and there are companies attempting to get lead-acid products certified to that. But the vast majority of the products that would include the Teslas, the LG Chems, which is LG Chem's UL 9540 is not under their name, it's actually under SolarEdge's name, and some other manufacturers that use their product. And so that's very important to understand. Most of the products are actually listed by Intertech, ETL, and there are a variety of UL 9540 products on the market today. They're less than 10, quite frankly. I mean, there may be sub-models of these things that puts it over 10, but as far as different manufacturers of products, pretty much somewhere between 8 and 10 products on the market. Enphase is an example. They're listed by UL. So you go down the list, and it's a pretty short list, and the preponderance of the products that are going into the field are going to be the Teslas, the Enphases, and the SolarEdges with LG Chem and other technologies. Those are probably the big ones. Delta has a product now as well. And again, those are all UL 9540 with lithium-ion batteries.
Okay. Because I know, like, when you're looking at Article 706, they list off all these different UL listings, not just 9540, but there's a whole bunch of different ones for light rail, etc. But since we have to follow the IRC and the NEC, then we have to go by 9540.
So yes, the IRC is constraining the options that are available in the NEC to one. Okay, now UL 9540 is an umbrella standard. We can get into a lot more detail about that, but it's an umbrella standard. It would include the UL 1973 standard, which is for stationary batteries and rail batteries. Okay, and so that's a subcategory. So the LG Chem battery, we're mentioning brand names here because there's very few products on the market. So the LG Chem battery is UL 1973 certified. So with that certification, now SolarEdge can take that battery. It's already had a pre-certification, if you will, that helps them in their certification of 9540, because that's a prerequisite standard for UL 9540, just as UL 1741 is a prerequisite standard for the inverter capabilities of the system and things like that. And any DC converter capabilities would have to go through UL 1741. So this umbrella standard 9540 covers whatever standards would have to fit underneath that in order to certify the whole unit as a system.
So let's say SolarEdge and SMA, since they can use the LG Chem battery and perhaps the BYD battery. So they go and they get their inverter certified with a different brand of battery, and then together those are listed as 9540.
That's right. It's a configuration. So SolarEdge could have 3 or 4 different configurations that are all 9540, but each one has a unique configuration. Same thing with SMA. Enphase has a solution that's integrated into their product. Tesla obviously integrated into their product. There's not a lot of options there. If you have an inverter that could be paired with multiple different storage sub-assemblies, they call them, then those storage sub-assemblies would be independent 9540 certification for each one. Everyone would be different.
What about for like a huge energy storage system that you're going to be using in like a utility scale type of situation? Are you going to have stuff 9540 certified for the big battery and the big inverter?
They can be UL 9540 certified, and I think some of them actually are. I would say that the fire code does not necessarily require 9540, so you'd have to go through you'd have to go look at the requirements of the fire code, because that's going to be covered under the fire code, to determine what, if it were not 9540, there may be additional fire testing requirements and things like that that would be required. So, because the 9540 process is really more designed about residential and small commercial. That's really its focus. It doesn't mean it couldn't be used for much larger systems. They're the ones that are going to be most likely to employ it. What they're trying to do is not only meet the requirements of the residential code and the building code, but also they're trying to meet the concerns of the local jurisdictions, okay? Again, who have seen all the hoverboard fires and everything like that. And so UL 9540 was really a way of saying, we're developing this new standard to try to improve the credibility and safety concerns related that surround lithium-ion batteries. That's what it started with. And because that was its main focus, it really didn't have a great avenue or pathway for lead-acid batteries to make it in. Now, lead-acid batteries are considered old school and so, last century kind of technology. But the reality is that lead-acid battery is a superior battery in certain applications. So for standby service, for instance, where the battery is kept at a float charge 24/7 is only used when there's a power outage or something like that, or a UPS or something. Lead-acid battery is substantially better than lithium-ion, cost-wise, performance-wise, and everything else. Okay. And so we typically use, in those applications, we use valve-regulated lead-acid batteries that are absorbed glass mat construction. Okay, so that's a very specific style battery that was designed from the ground up as a standby battery. So for standby service, which that's one method of storage batteries that could be used in commercial, residential, and industrial applications, lead acid would make more sense. And that's why UL 9540 needs to allow that. Now, what kind of market is there for standby only service in a residence? Maybe it's kind of small right now.
I know a lot of people doing it. I mean, that have, old style net metering where the price is the same all the time. It's
right.
Kind of makes sense.
And that's what I have on my house. I have standby. I operate my batteries in standby service because I have a flat rate. I don't have any advantage to dispatch the battery. In fact, if I were to dispatch the battery on a daily basis, maybe at the peak times of the utility, all I'm doing is choosing to waste my money, and help the utility. And what have they ever done for me? So, no.
I'm sure they wrote you a check before.
Great people. But the point there is that there's no financial incentive for me to do that. Now, if the utility wants to come to me and say, I will give you a financial incentive to actually operate your batteries in a way that's beneficial to you or to the utility, and I'm willing to give you some of the benefit, kind of provide an incentive to you as a benefit, then I'll think about it. Then it would become a financial decision. So in the future, we're going to actually, the ideal situation for the whole energy storage industry is to have price signals from the utility that tell us when it's advantageous to dispatch our batteries. Now, we can do that with a very simple time of day rate tariff, and that's typically what we have in California and other places do that. But that's a very simplistic approach. We could have situations where the utility is desperate for power. That desperate for power may not match exactly with the time of day or whatever, but because they're desperate for it, they're willing to give us a lot of money for us to dispatch our battery. Okay, well then, let's go with that.
We can tell people that they can go purchase a copy of UL 9540 for somewhere around $500, $1,200.
Depending on how much cash you have.
And any of these UL standards. And there are digital view options.
Correct. But unless you're actually working at a company that's wanting to do UL 9540, it's a complete waste of money to think about these standards. And there is a digital view option. It just takes a while to get to it. It's not easy if you're interested in learning about it. And then if you want to participate on the standards technical panel, you can apply to get on the standards technical panel. And if they like your resume, then you can get on the standards technical panel and you can view it for free there.
Wow. I guess you have a lot of those, huh?
I do. And I'm on the standards technical panel for 9540.
Wow.
So that's the three ways of doing it. But let's move on. Now, there is an exception in the IRC to the 9540 requirement. I think personally it's silly, but fine. I have my own opinions. I can keep them.
Yeah, and there's multiple exceptions.
There's multiple exceptions, and this is the first one. It's where approved, repurposed, unlisted battery systems from electric vehicles are allowed to be installed outdoors in detached sheds located less than 5 feet.
Not
less than 5 feet. From exterior walls, property lines, and ways. Okay, this is a wonderful opportunity for a series of great jokes. Okay, so this is the above ground burial of your electric car. So you're going to take your electric car, you're going to put it in the shed in the backyard, and you're going to hook wires up to it. And apparently, the International Residential Code, you put 5 feet from the house, have on at it, brother. So whatever, fine.
Well, it's like it's recycling, and
Yeah.
you can take your old EV battery out there and
Just hook her on up,
Yeah.
And so then the question is, how would you do that legally? You would have to follow the National Electrical Code if you're going to do it legally. And then the question is, okay, how do you do that? I'm going to dismantle my Tesla and I'm going to take all the batteries out of it. I'm going to hook them up. I'm going to make Powerwalls out of them or something like that, and then I'm going to have some whiz bang dude like do a battery management system for me. I'm just going to rip all that hardware out of the car and basically do a car on a wall.
well, they got YouTube videos on that already. Yeah.
Oh, I'm sure they do. And so yeah, you follow your YouTube video, and apparently the IRC says it's fine, and basically says keep it 5 feet away from everything. So if it catches on fire, who cares? So if you can do that, I would think you can do a lead acid battery all day long, all that kind of stuff, but it doesn't specifically say you can. Okay, battery systems that are an integral part of electric vehicle are allowed to be provided that the installation complies with 625. Now this is the 2018 IRC, so it's going to be based on the 2017 or even the 2014 National Electrical Code. So you got to be a little careful here, because when it makes that reference, you got to understand which version of the code is, because we've changed some of these references around
That's a good
and stuff
question.
like that.
So when it refers back to an older version of the NEC and your state has adopted a newer version, which one do you use?
You would use the older version of where that went. So let's just say 625.48, and we'd have to look it up, moved to 625.50, okay? Well, you might use the information out of 625.50 in the current code because it relates to that. But you have to go back to the 2014 NEC and find out where that was and see if it matches up or not. Because the correlation, there's no attempt to correlate with the residential code. The residential code needs to correlate with this. So in the 2018 code, and I know this for a fact, since the 2017 NEC was not published when the 2018 IRC was being written, they don't use the 2017 NEC, even when it seems to be 1 year less. It wasn't published yet. So you would have to go back to the 2014 NEC, and we can look that up and make sure that complies. Now, how that relates and everything, 625 is about charging of electric vehicles.
So this is the 2018 IRC, and are you saying that this would be based on the 2014 NEC, not the 2017?
That's correct.
They sure go backwards in time.
Yeah, they do. So that's just a challenge, but let's just talk about it for a moment. So now we're in the 2014 NEC, and we would look at whatever is required there. But we're saying it's an integral part of an electric vehicle, so fine. So we're going to have some kind of transfer equipment that could basically take the power off the electric vehicle, would charge and discharge the electric vehicle while it's sitting somewhere. And that part of it that is not part of the vehicle would have to match the National Electrical Code. So there's going to be some plugs or whatever. And so I can use my connector that's on my class 2 charger, whatever. That might be a method to make that electrical connection in and out of the battery. There's various ways that might be able to be done.
Can't wait for the time when we can start feeding the grid with our cars.
That's right. It's coming soon.
And then the other exception, less than 1 kilowatt hour.
Yeah, and so that's basically saying we can disregard little guys. Now the question is, what if you had a whole bunch of little guys? That's an argument for another day, but...
So in other words, since there's no lead acid battery 9540, you cannot use lead acid batteries according to the IRC on your house. Is it? I mean, it's kind of a mistake or something, but...
Well, yes. Essentially, the 2018 code rules out lead acid batteries for the time being because there's no specific products available on the market. Now, I would argue if you're going to allow people to rip batteries out of electric vehicles, you sure as heck should be allowed to use lead acid batteries because they're way safer.
And then I always thought I was interested in Article 480. It says lead acid batteries don't have to be listed, so you could make them in your garage.
You could. That would be a waste of money and time and effort.
Or maybe you could just take old ones out of your car and use those.
You could do that too. They're also not great batteries for this application. They have a fair amount of losses in them. So, standby batteries, lead calcium batteries and all, they tend to be a little more expensive, but better for cycling service and standby service. So,
well, even if you put them in your car just to run it around the block once, you stick a bunch of Trojan deep cycle lead acid batteries in there, then you can start using them for your house.
That's right.
Yeah.
You could basically say, well, they were an electric car.
Or just
you could put
deliver
them
in your Tesla.
That's right. You can put them in the trunk of your Tesla and then take them out And so, yeah, all those things,
It's always good to know how to get things done.
those exceptions are so silly. Why not? Let's keep going.
Let's be more silly.
Let's be more silly. Okay, so this is kind of the main installation requirement. And first of all, we always have to follow the manufacturer's instructions for a battery, whatever those may be.
Kind of like anything that's listed.
But it also states that it can't be in a habitable space in a dwelling unit. So what's a habitable space? You'd have looked up what the definition of a habitable space is. Well, a habitable space certainly is things like bedroom is habitable. A living room is habitable.
I would say too that any place that you heat up, if you live in a cold place, is habitable, and that's where you want to put your batteries if you live in a cold place.
And that's generally true, but there are some exceptions to that. A hallway is not considered habitable, okay? Even though it's heated and cooled. And a bathroom is not considered habitable.
You don't want to put your battery in the bathroom.
Well, you know, you can keep it clean easier, right? You could take the, you know, if you have like a
wash those terminals with
a
your
wand
toes.
on your shower, you can wash the terminals off with that sucker. But no, that's generally would be frowned upon to have electrical equipment in your bathroom. The point is, this language, which was kind of a first attempt at trying to give people installation direction, is poor. A garage is not habitable. So there's an example of something that's clearly not habitable, and where you want people to put batteries that is in a safe place as well as a tempered location that doesn't get generally as hot or cold as the outdoor.
Like I remember when I lived in Alaska, people would always put you know, they have these off-grid systems, and they always put the batteries like under a bench in their living room because it's going to be warm enough where the batteries are going to work.
Sure. Right. And now there is the idea in the 2021 code of this special listing that would be a residential listing that has not been actually done yet. It's a standard that's in play, but nobody's actually built a product to meet this new proposed standard. And that would be a product that you could put anywhere. So it would be an appliance. It would be something that you could put, you know, make your furniture out of or build your furniture around, if you will, like you were just pointing out.
Well, you ever see the Sonnen battery brochures? They have them in the living room.
Yeah,
the
as lovely.
fireplaces going.
Yeah, and Tesla and their early Powerwalls, the pretty curved Powerwalls, those were always in the living room as the, you know, main display of the house. That was kind of your feature of your house.
Show how cool you are.
To show how cool you were, right? But that's not allowed right now. Okay, you have to follow NFPA 70, that's the National Electrical Code. Listed in according to UL 1741, well, you don't even have to say that because 9540 requires 1741, but that's, UL likes to get their name in the building code as much as they can, so since they can, they do. And then they have to be listed for utility interactive if they're going to connect to the utility. Well, that's already covered in the NEC, so that's redundant language. I tried to get them to take that stuff out, but
they should just take the whole thing out.
Exactly. Ventilation. Here's a great one. Indoor installations that include batteries that produce hydrogen or other flammable gases during charging shall be provided with ventilation. Now, what does that mean? Well, yeah, this is talking about normal charging. This is not talking about something really bad having abnormal conditions. So the only batteries out there currently that are under heavy use would be lead acid batteries that would have a ventilation need. And as you point out in your sub box here, lithium batteries do not produce hydrogen, while lead acid batteries do. So if you had a flooded lead acid battery that got UL 9540 at some time in the future, none exists today. So ventilation is a non-issue. It just doesn't even belong in the code at this point. But let's just say that, you know, the code covers future applications too. So let's say in the future, we get a UL 9540 battery that uses a flooded battery, which is totally possible. Then that area would require mechanical ventilation according to M1307.4.
It's a little fan or something.
Yeah, so the problem with that is it's going to require calculations for hydrogen, you know, and all this kind of stuff, which I'm absolutely against, personally.
Or you could just have like a hydrogen sensor in there.
Yeah, hydrogen sensor might be a way of doing it, which pretty much any smoke sensor is going to pick up a hydrogen signal. But also, we do lots of ventilation for combustion appliances. So combustion appliances like water heaters and things like that require an outdoor air source and things like that. And so those types of ventilation requirements, which are very, very common in any house that has a gas water heater, would be way more than would ever be needed for a flooded lead acid battery. And so in the past, when Y2K happened, and if you're too young to know about Y2K, look it up, Google it.
Yeah, what year did that happen?
That was sometime around 1999.
I was going to call the emergency number, but I couldn't remember the number for 911.
That's right, exactly.
Happened.
So 1999, and that's when Prince was partying. He's got a song about that. Look that up.
Oh, we'll play the soundtrack.
That's right, in the background. So all the systems that were going in at that time were lead acid, because lithium-ion was a dream at that point. It wasn't a reality. So lead acid was the standard, and everybody was putting in lead acid batteries to take them through the apocalypse that was imminently going to happen on midnight December 31st. So anyway, that of course didn't happen, but all those systems that were going in were lead acid batteries, and a lot of them were flooded batteries. Most of the stuff that we were trying to encourage people to do were valve regulated AGM batteries, absorbed glass mat batteries, because they were better and safer than normal flooded batteries, but people put in flooded batteries. And then, so we had a lot of jurisdictions asking what should we do for ventilation. And my recommendation, a lot of people did this, is say, whatever ventilation would be required for a gas water heater, use that. And so if you're putting it in a garage that already has a gas water heater, you're good to go, because you already have the required ventilation.
Yeah, maybe that pilot light will get rid of some of that hydrogen.
There you go, burn it up. But if you're going to put it in like a utility room in a house, well, make the utility room of however you would need to have for a combustion appliance in that utility room. And that's going to be more than enough. That's something they could relate to. They understood how to enforce it. Rather than saying, I need you to hire an engineer to calculate how many hydrogen atoms can fit on the head of a pin, and then I want to give you a calculation for how many times the wheel has to spin on the fan in order to get that hydrogen out the door. That's absolutely ridiculous and would be more expensive than it was worth to come up with that calculation, when you could do something that was very simple, straightforward, and something that the average inspector inspects every single day. As part of their job.
Okay, let me do a disclaimer. Don't put a hydrogen source next to a pilot light.
Probably not. Protection from impact. So this is where it gets fun, and this is obviously specific about vehicle damage. Okay, even though the title is protection from impact, stationary storage batteries installed in locations subject to physical damage, vehicle damage, shall be protected by approved barriers. What's approved barriers? And what's subject to physical vehicle damage? Neither thing are defined here. This is a huge problem for jurisdictions and for installers, because this is in the code. It's in the 2021 code. There's no information about what it means. And so people can make stuff up. And that's the problem with these kinds of open-ended ideas. It was put in there for people to think about the idea that a vehicle could run into electrical equipment. Well, we already don't allow vehicles to run into electrical equipment in general in the National Electrical Code. We already have that covered. But somebody thought this was important to put into the code. And it's one of the very early things to go into the IRC as a requirement. And it's hugely problematic because it doesn't give us any background. So the ICC actually did produce a document, and I'll show you that document. We can put it up on the screen, that goes through and gives an example of what vehicle protection might look like for various appliances like water heaters and other things like that might need protection, including, and certainly energy storage would be included in that. And that's where it basically allows or shows that installing on the sidewalls of a garage, for instance, is fine, but the end walls would need some kind of barrier or protection. And they recommend parking bollards or parking curbs. I should say bollards or parking curbs would be a better way to say that. Of course, it could be on the outside of the house, but then the issue is, well, if you've paved directly up to an area where you have an energy storage device, well, then could somebody back into it while they're turning their car around or something like that? Well, yeah, that's true. And so how high up off the ground would be acceptable and be out of the way? Would you need to put some kind of a curbing or something like that to protect if you had paving right up to it? So there's a lot of little issues there that have not been answered, and those questions are being discussed right now as we speak for the 2024 IRC. They are not covered in the 2021 IRC at all. The 2021 IRC is very similar to this. So again, there are a lot of HJs out there that are going to scratch their head and go, what do I do with this? And we have some recommendations, and we're going to talk about those recommendations.
You can just hang one of those balls in the garage, that
Absolutely.
goes right at your window.
You could have a proximity sensor that just sets off like an alarm or something like that when you get close. It has a voice comes out and it says, do not proceed.
But do proceed with your education. So, to learn more about solar and energy storage, go to SolarEdge.com, where we have NABCEP classes and all kinds of learning materials. That's SolarEdge.com.